Hello, this is the report for Lab 5, Magnetic Braking for Physics 2. Brief introduction to the purpose of the lab. The goal of this lab was to compare analytical and experimental data using Faraday's law to simulate dropping a magnetic dipole or bar magnet through a tube of aluminum foil, as well as visualizing the trends of magnetic braking analytically. Quick spoiler on the right, this is our model showing the effect of the magnet falling through, and this is incomplete graph during the duration of the model. On to the physics principles. Over here is an image of the data being collected. Some main principles: Faraday's law, change in magnetic field induces a electromotive force. Ohm's law, current is directly related to electromotive force. And resistivity of a material, where the resistivity is inversely related to the resistance. So these equations, the magnetic field of a dipole following this off-axis equation, we have the magnetic flux is equal to the magnetic field passing through an area, EMF related to change in flux, and current change in potential difference equals current times resistance. System being the magnetic dipole, the surroundings being the aluminum foil, and the earth pulling down on it. Onto the experiment. This is the data collected in the experiment. Multiple trials were conducted to yield the following results. Dropping speed and position held static. Basically, we made sure that the tube was not moving up and down during the drop, and also that the dipole was dropped at the same speed and the same height above. Onto the code. These are just some of the snippets changed. Here are the starting values. For example, the length of the tube, the width of the aluminum foil, inner radius, blah blah blah. Force of a dipole following that equation we showed earlier. Calculating flux, same thing. And computing the B field at each ring. We were modeling the tube as a bunch of rings stacked on top of each other. Alright, onto the results. Final analytical model being 1.724 seconds, as measured by this graph, and the average experimental being 1.66 seconds. So fairly similar results, good model. These are pretty close numbers in the scheme of things. Quick note, what this graph tells us: as the tube is dropped in, there's a point in which the force from the magnetic field is higher than the force of gravity, which causes it to slow down. Now, that is because the force is related to the current, which is related to the EMF, and the EMF comes from the change in flux. So as the flux is changing more, there will be more force. So once that comes, it slows it down, causing the change in flux to be smaller. So there's a point where it reaches equilibrium, and the force of gravity is equal to this induced force by the aluminum foil. And there's a point where it reaches the bottom, and there's not enough to overcome that force of gravity. So, the what if questions. What if the resistivity of the conductor were reduced as close as possible to zero? How would the dynamics of the falling magnet change? So, based on our equation, we talked about how resistivity is inversely related to resistance. That means that as resistivity increases, resistance decreases. So a very small resistivity means that the resistance is very large. And knowing that current is directly related to the force from the equation, we know that as the resistance increases, the current must decrease because the induced electromotive force is constant. So that means that as resistivity is decreased, the force is also decreased. So as it approaches zero, the force approaches zero. So if the holes or slots were cut into the tube, this would affect the ring currents in the model, because since we model this as a bunch of rings stacked on top of each other, if there were slots cut in the tube, then that ring would not be accurate. There would not be an even z-axis force applied on the conductor. It would have some x-axis number that would cause it to spin and cause some sort of change in the way it falls, causing the physical experiment to yield different results than the experimental model or analytical model. Thank you.